Hey guys, welcome back, I'm Jay. This is the EC2 Introductory Lab. In this episode, we're gonna get our hands dirty and get started with Amazon EC2. We're going to launch an EC2 instance, connect to the EC2 instance remotely, install a web server, and deploy a simple web page. We've made a Super Kitty Piano sample website for this lab. You can go to superkittypiano.com and access this project. Hope by the end of this episode, you'll know how to deploy a website like this onto AWS EC2 in less than 5 minutes. Okay, we're on the AWS Management Console, let's go to the EC2 service. You can find EC2 using the search box on the navigation bar. This is the EC2 dashboard. As you can see, we don't have any instances running. Initially you have a default security group and default VPC and subnets in each region, so that you can easily launch EC2 instances using the default security settings. You can quickly launch a new instance by clicking this orange Launch Instance button. Or alternatively go to the Instances page. Let's click the Instances link on the side menu, and go to the Instances page. You can manage EC2 instances on the Instances page, such as start, stop and terminate instances. The instance list is empty at the moment. Please note the EC2 service is a regional service. For example, if you've created an EC2 instance in Asia Pacific Singapore region, you need to switch to that region to see the instance created there. We're in the US East 1 Northern Virginia region at the moment. Let's go to the Singapore region and take a look. We have one instance running in this region. You can only manage EC2 instances in the same region as you created them. Be careful if you accidentally create an instance in a wrong region and switch to a different region, you might end up forgetting the running instance, and paying for the unintended bills. We no longer need this instance, so we can go ahead and terminate it. Select the instance and click the Instance State drop-down button, click Terminate Instance. It might take a couple of minutes terminating. The EC2 instance is now terminated. Let's switch back to the US East 1 region and launch our first EC2 instance. Click on the Launch Instance button. It's gonna take us to the Launch Wizard. First, let's choose an Amazon machine image here. Here is a list of all the available AMIs in the current region. Each AMI has a different set of operating systems and software bundles, such as Amazon Linux, third-party Linux distributions, Mac OS and Microsoft Windows. Some AMIs are built for specific purposes, such as deep learning optimized AMIs with common deep learning software packages. You can choose a custom AMI under My AMIs tab. You can also choose third-party paid AMIs from AWS Marketplace. Select free tier only and you can see all free public AMIs in the current region on AWS. We're gonna use Amazon Linux 2 AMI. It's built with AWS optimized Linux, using HVM virtualization type and SSD volume type. It supports EBS volume as root device type. Each AMI has a unique AMI ID across all AWS regions, which means even two identical AMIs in different regions have different AMI IDs. Check the 64-bit x86 option and click the Select button. Next, we're gonna choose an instance type. AWS offers a variety of EC2 families and types under 5 broad categories. They're general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. The general purpose T2 micro instance is free tier eligible. It comes with 1 vCPU and 1 GB memory. Let's choose the T2 micro instance and click Next. For the instance details, we're gonna keep the default values. However, let's take a look at available options. You can choose how many instances to launch at once. You can also launch them into an auto-scaling group. We only need 1 instance for now. You can request spot instances and get significant discounts. Check the spot instance option, you can see the current spot prices in this region. The spot price is the price you're gonna pay. You can set the maximum price you're willing to pay per instance hour. Your instance will only run when the maximum price is greater than the spot price. We're gonna launch the on-demand instance. So we can uncheck the spot instance option. AWS has created a default VPC in each region and a default subnet in each availability zone. The default VPC and subnets have all the components necessary for the internet connection. You can create new VPC and subnets if you have a specific requirement. We're gonna launch the instance into the default VPC and subnet. We want AWS to auto-assign public IP from the IP address pool, so that the instance can be reached over the internet. This option is enabled by default, when you choose the default VPC and subnet. Public IP is different from elastic IP. Public IP is associated with the instance until it's stopped or terminated. The new public IP will be assigned after the instance reboots. Whereas EIP can be persisted even after the instance is stopped. Optionally, you can launch the instance in a placement group that benefit from great redundancy, or low latency and high throughput network performance, when you have a fleet of EC2 instances. We don't need the placement group for now. You can reserve capacity for significant savings, if your application has stable and predictable workloads, and needs to run for a fixed period. You can launch EC2 Instance using capacity reservation, if there are available capacity and matching attributes, such as instance type, availability zone and platform. You can assign an IAM role to the EC2 instance, so that the instance can assume the role, and perform certain tasks on AWS resources. For example, if you need the instance to send data to an S3 bucket, you need to assign the IAM role to the instance profile. EC2 uses an instance profile as a container for an IAM role. When you create the IAM role using the console, it creates the instance profile automatically and gives it the same name as the role. You can choose whether to stop or terminate the instance as the instance OS level shutdown behavior. The default shutdown behavior is stop. You can optionally enable the hibernate behavior and termination protection. CloudWatch collects and analyzes the instance metrics. By default, the basic monitoring is free, where data is sent to CloudWatch every 5 minutes. If you need more granular data, you can pay for the CloudWatch detailed monitoring, where data is available in 1-minute periods. We only need the basic monitoring. You can launch EC2 instances onto a multi-tenancy host using shared hardware, or launch instances onto a single tenancy host using dedicated instance or dedicated host. We choose shared hardware for the instance. Under the advanced details, you can configure the EC2 instance metadata and user data. Metadata is the information about the instance, such as hostname, events, and security groups. You can use metadata to manage the instance, when you connect to the instance. User data is a configuration script that EC2 instance can run during launch. We're going to talk about user data later. For now, let's keep the default values for all options, and click Next. Now let's add storage to the instance. First, we need to configure the root storage device. The root storage device contains all the information necessary to boot the instance. You can set the storage size and choose the EBS volume type. You can choose to delete or persist the volume on instance termination. If you choose to persist the volume on termination, the volume can then be reattached to a new instance for quick recovery. You can also encrypt the EBS volume for security purposes. Snapshots of the encrypted volume are automatically encrypted. Volume restored from an encrypted snapshot is also encrypted. You can add additional volumes to the instance. For root volume, you can only choose general purpose SSD, provision IOPS SSD or magnetic standard volume type. For additional volumes, you can choose general purpose SSD, provision IOPS SSD, cold HDD, throughput optimized HDD or magnetic standard volume type. Free tier eligible customers can get up to 30 GB of EBS general purpose SSD or magnetic storage. We only need the root volume for now. Let's remove the additional volume and click Next. Now let's add tags to the instance. A resource tag consists of a case-sensitive key-value pair. You can use resource tagging to group resources and manage them in a group. For the first tag, we're going to set the key to name and value to web server. The name tag is a special tag. It's going to label the instance on the instance list. By default, the instance tags are applied to both instances and volumes. You can add more tags if you like. We only need one tag for now, so click Next. Finally, we're going to set the security group for the EC2 instance. A security group acts as a firewall with a set of rules that control traffic of the instance. For example, if you want to set up a web server for the internet, you can add rules that allow access to the HTTP and HTTPS ports. Security group rules are permissive and stateless. You can only allow traffic, but not explicitly deny traffic with the security group. You can create multiple rules in a security group, and assign up to 5 security groups to an instance. When you configure the security group, you can either assign an existing security group, or create a new security group. Each security group rule consists of traffic type, network protocol, port range, traffic source, and description. SSH stands for Secure Shell. It's a network protocol for secure access to remote computers over an unsecured network. We need SSH to connect to the EC2 instance remotely. SSH communicates using port 22. If you set source IP to all 0 address, it'll allow traffic from anywhere. As a security best practice, AWS recommends setting the source to known IP addresses. We allow SSH connections from anywhere for now. For EC2 instance to serve internet traffic as a web server, we need to add 2 more rules to allow HTTP and HTTPS connections. HTTP communicates using port 80, whereas HTTPS communicates using port 443. We allow traffic from anywhere over the internet. Click Next and review the instance detail before launching the instance. Everything looks good. So click Launch. Before you launch the instance, you need to specify the key pair for secure connection to the EC2 instance using SSH. A key pair consists of a public key and a private key. You can use an existing key pair or create a new pair. We name this key pair as web server. You need to download the webserver.pem file for the secure connection. As a security best practice, you should always store your key pair securely. Let's launch the instance now. We've successfully created an EC2 instance. Let's go to the instance page and have a look. The instance is launching now, as the instance state is showing pending. It might take a couple of minutes for instance to be ready. Let's refresh the instance list. Now the instance is up and running. You can view the instance details under the instance list. When you create the EC2 instance, your instance is assigned with a private DNS and IP address, and a public DNS and IP address. The private IP address is always associated with the instance until it's terminated. However, the public IP is disassociated with the instance when the instance is stopped. A new public IP will be assigned to the instance after the reboot. Let's stop the instance and have a look. As you can see, the private DNS and IP address are still available. However, both public DNS and IP address are no longer available after the instance is stopped. After we restart the instance, a new public IP is assigned to the instance. The private IP is still the same. Congratulations guys, we've successfully created the first EC2 instance. You can remotely connect to the EC2 instance from the local computer. For Mac and Linux users, you can use SSH client to securely connect the EC2 instance from the terminal. You can search and find the terminal app. For Windows users, you can use OpenSSH client or PuTTY to securely connect the EC2 instance. We recommend you to use OpenSSH from command prompt. By default, OpenSSH is enabled in Windows 10. You can also install OpenSSH if you use earlier versions of Windows. Click Start and search for CMD, you can find the command prompt. SSH stands for Secure Shell. It's a secure network protocol for accessing the remote server over an unsecured network. Here are the steps for the SSH connection. You need the private key generated from the EC2 key pair for the SSH connection. The private key is a .pem file. Open the terminal and run the chmod 400 command to change the file permission of your .pem file to private. Connect to EC2 instance with its public DNS using SSH command. First, let's go back to the AWS console. Select the EC2 instance and click the Connect button. AWS offer different options to connect to your EC2 instance. You can use an SSH client on your local computer, or browser-based SSH connection. Alternatively, you can use AWS Session Manager. We're gonna connect using SSH client from the terminal on the local computer. Let's open up a terminal window. First, we're gonna locate the private key. It was downloaded to the Downloads directory. CD to the Downloads directory. ls to show a list of files in this directory. The private key is the webserver.pem file. Use chmod 400 to change the permission of the .pem file, so it's not publicly accessible. Otherwise SSH won't work. Now let's connect to the EC2 instance using the SSH command. When you connect to a new remote host from the local machine, you'll be asked to add the remote host as a known host. Simply type yes to continue. We've successfully connected to the EC2 instance using SSH from the terminal. Once we've connected to the EC2 instance, we're gonna install a web server and deploy a simple web page using the following commands. Please note that some commands are different if you're running different versions of Amazon Linux. We've launched the EC2 instance from Amazon Linux 2 AMI. So we're gonna use commands for Amazon Linux 2. First, let's run the sudo su command to switch to the super user on the EC2 instance. We need the superuser's permission to run all the commands. Next, run the yum update command to update the necessary software and security packages. This might take a while if you're updating the system the first time. As a security best practice, you should always keep the EC2 instance up to date. Now, let's run the yum install httpd command to install the Apache web server. Apache web server is one of the most popular open source web servers. We need the web server to host a simple web page. Run the systemctl start command to start the web server, as we're running Amazon Linux 2. If you're running Amazon Linux 1, use the service start command instead. When you stop and restart the EC2 instance, the web server will stop running. We want the web server to start automatically at each system boot. Run the systemctl enable command for Amazon Linux 2. Use check config command, if you're on Amazon Linux 1. We're going to create an index.html file as a simple web page, in the web server directory. The echo command will write hello world to the index.html file. The EC2 metadata is the host information about the instance, such as hostname, events, and security groups. You can retrieve EC2 metadata from the EC2 instance using a fixed URL. Run the curl command to retrieve the public hostname and display it on the web page. We've successfully installed a web server and created a simple web page. Now, let's have a look at the web page. Go back to the AWS console and copy the public DNS of the EC2 instance. Open up a web browser and go to our web page. Congratulations guys, our first Hello World website is up and running. It's also displaying the host information retrieved from EC2 metadata. Manually running commands is not the best way to set up the EC2 instance, if you want to launch multiple servers, or if you have many commands to run. You can use EC2 user data to configure the instance to automatically run scripts during launch. You can put multiple commands onto the user data script. The EC2 instance will run these commands. If you launch more than one instance, user data is available to all instances in the reservation. Here is the sample user data script we're going to use to launch another EC2 instance. It's going to update the system, install a web server, and create a web page automatically for us. Let's go back to AWS console and launch another EC2 instance. You should be familiar with the launching steps. Click Launch Instance button. We're going to keep the same AMI, instance type and instance details. Except this time, we're going to configure the user data script. Go to the advanced details, copy and paste the script onto the user data field. The script begins with the hashbang mark, to tell the kernel to run the script. It's going to update the system, install the web server, and create a web page automatically during launch. We're going to keep the same settings for the storage. For the resource tags, we're going to name this instance web server 2. We've created a security group previously. We're going to use the same security group for the new instance. For the SSH connection, we're going to set the same key pair for the new instance. We've successfully launched a new EC2 instance with user data. It might take longer to initialize the instance, as it's running the user data script. Updating the system and installing the web server can take some time. The EC2 instance has completed the initialization, and passed the status checks. Let's grab its public DNS and check the new website. Hopefully EC2 has installed the web server and created the web page for us. The new website is up and running. This time we let the EC2 install the web server and deploy the web page for us. User data is a much better way to run commands and perform certain tasks during the instance launch. Before we wrap up this lab, let's terminate the EC2 instances we've created, as we no longer need them. Make sure you don't have any unused resources running. It's a good practice to optimize your AWS costs. Here is a challenge for you. Remember the Super Kitty Piano website we've shown you earlier. Go to superkittypiano.com and join the project. Customize the website and see if you can make some improvements. You can get the source code on our GitHub page. Try to deploy the Super Kitty Piano website onto AWS EC2 using user data. In this episode, we've launched an EC2 instance. We've connected to the EC2 instance remotely using SSH. We've installed a web server and created a simple web page by running commands manually. Finally, we've configured EC2 instance to run commands automatically at launch using user data and shell scripts. Okay, that's all for the EC2 Intro Lab. Thanks for watching and see you in the next episode.
Hope you've enjoyed watching this episode. If you like the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.